For the purposes of the topic which we are going to engage ourselves with, we must be familiar with the statement which says express the following as a single rational expression. We are given here rational expressions, two being added, number 1 and number 2. Now let's see how we would go on with this. Let's say here solution for let's start with number 1. It's clear that number 1 is very easy and straightforward because of the reason that we've got common denominator x squared plus 1. So this is 2x over x squared plus 1 plus 3 over x squared plus 1, which is just as good as having 1 over 5 plus 3 over 5, because these fractions are, you've got the same denominator, common denominator. The task reduces to adding the numerators and retaining the denominator, which will end up being 4 over 5. Now we'll do exactly the same thing in this situation, which would say we write our common denominator once, because we want to express this as a single fraction, then we add up the numerators as 2x plus 3. Now in the second situation, whereby we've got 2x over x squared plus 1 plus 1 over x plus 1, this is just as good as we had x plus y as unlike terms, and we can't just add up and get a single term or a single expression. So which means then this second case here is more challenging, and then let's engage with it and see what we can do. Let's get rid of this. Now you are dealing with number 2. Now number 2 says we've got we'll get to add 2x over x squared plus 1 plus 1 over x plus 1. Now this situation is like a situation which resembles unlike terms. It's just as good as we had c over b plus a over d. This kind of situation, we cannot simply add up to get a single expression as we did in the first example. Now, but we need some facts about numbers. For example, let's think of 1 as a special number. Let me remove this here for a while. Let's think of 1 as a special number. We have here c over b plus a over d. Thinking of 1 as a special number, 1 is equals to 100 over 100 equals to 2 over 2 equals to b over b equals to d over d, and so on. Also 1 times a is equals to a times 1 equals to a. This is very important to be able to continue. So in this case, I can multiply c over b by 1 and still have c over b. In this case, I'm going to take 1 in terms of d over d plus a over d multiplied by 1 in terms of b over b. Then this takes us to the situation exactly similar to the first example, whereby we've got a common denominator which is bd. So this we can take to a single fraction, denominator bd, and numerator what we're going to have here c cd plus a b. Then we've achieved what we wanted to do here, that is expressing this as a single fraction. Now if we look at this carefully, we can say this is our b and this d. In this case, the denominator for this will have to look like this. We're striking some similarity there. So we can say now x squared plus 1 multiplied by x plus 1 will be the denominator for a single fraction. Now we then use our normal addition of fractions. We have to divide this by this denominator, this common denominator, to get x plus 1, and that x plus 1 will then multiply 2x, like we've got here cd. So we're going to have here 2x multiplied by x plus 1. It's like we're moving from this step to this step. We take b and multiply this denominator and get d, then that d multiplies c and we get cd. That's what we've got there. Then continuing, we add plus, take this second denominator, divide the common denominator, we get x squared plus 1. Then we're going to have 1 multiplied by x squared plus 1. So in this case here, these two expressions are exactly expressing the same stage of addition of these two fractions. In this case, we must note that from here we are able to reverse this to this stage and to reverse that to the initial stage there. So we see here there's no problem there. Now what we need to do now is to remove the brackets and simplify. We remove the brackets and simplify, which will give us the expression x squared plus 1 over x plus 1. Now we note that here we're going to have 2x squared plus 2x, and this side multiplying by 1, we're going to have x squared plus 1. Now we've got 2x squared plus x squared, which will give us 3x squared plus 2x plus 1. Then we'll say we've managed to express this sum of two fractions as a single fraction as required by the order of this exercise. Now, what we're going to be doing, that's why I said this should serve as motivation for what exactly we're going to be doing. What we're going to be doing is not to start from an addition of two terms to a single fraction, but our task now will be, say we're given a similar expression to this one. Let's say 2x over x plus 1 multiplied by x minus 2. We are asked to determine the partial fractions which add up to this single fraction. In this case, what we're being asked to do, we're asked to determine fractions of the form a over x plus 1 plus an unknown b over x minus 2. In this case, b and a are known because we are starting from this point. In other words, we are doing the reverse of what we've been always doing, adding two fractions to get one. In other words, now we are splitting a fraction into its constituting parts, and that is what we're going to, that's why we're going to call this topic partial fractions. In other words, we're splitting a given rational expression into its constituting partial fractions. I think up to there, this is a motivation and putting it clear what exactly we're going to do. But the most important thing is that we must understand that this topic is a short topic, but which is used in several other topics to solve other problems. Hence, it's important to be able to be very fluent in it and be able to work with it in the later stage. We're going to stop there and call this a motivation and the spelling of the problem of which we're going to be engaged with for some time now. Thank you.